At first glance, it looked like just another frozen traveler crossing our skies. A faint blur, a streak of reflected sunlight, on an otherwise predictable trajectory. Yet from the moment astronomers began to track its path, something about 3I Atlas seemed subtly different. Its light curve fluctuated in ways that hinted at complexity beneath the surface, as though layers of mystery were concealed within that dim glow. Over the months leading up to its perihelion, the moment it would sweep closest to the sun, anticipation built quietly across observatories worldwide. This was no ordinary visitor from the depths of space. By late October, telescopes from Hawaii to Chile, from the Canary Islands to Japan, were locked onto it. The object's approach toward the inner solar system was not merely an astronomical curiosity, it was a chance to watch the solar furnace sculpt and awaken a body forged beyond the frozen edges of the Kuiper belt. Every time a comet approaches the sun, the heat breathes life into it. Ices sublimate, jets of vaporized gas explode into space. The coma blooms into a luminous halo. It is one of nature's most reliable transformations. Light meets ice, and the universe responds in shimmering, predictable physics. Except this time, it didn't. As 3I Atlas neared its perihelion, something began to happen that confounded every predictive model astronomers rely on. Instead of glowing brighter, its light began to fade. Instead of expanding, its surrounding coma began to shrink. Within a matter of hours, the brightness dropped by nearly half, a collapse that rippled across every data stream, every instrument tuned to it. It was as if the object had felt the touch of sunlight and recoiled, shutting down rather than awakening. For the scientific community, this was not merely a deviation, it was a contradiction. Thermal physics dictates that increased solar radiation should trigger increased activity. The heat should melt volatile ices, releasing plumes of gas and dust into space. The resulting pressure should push the object slightly off course, producing a characteristic tail visible even to backyard telescopes. Instead, 3I Atlas seemed to retreat from the laws of thermodynamics themselves. Why would a body so close to the sun suddenly go quiet? What mechanism could extinguish such expected behavior? As days passed and data accumulated, researchers began whispering comparisons that no one dared put in official reports. The symmetry of its temperature readings, the precision of its light variations, the strange uniformity of its spectral emissions, all suggested not randomness, but regulation. The kind of regulation associated not with chaotic natural processes, but with control. Could there be feedback systems operating within? Could this be more than a simple mass of ice and stone? Theories proliferated rapidly. Some invoked exotic chemistry. Perhaps 3I Atlas carried molecular structures from beyond the interstellar medium, substances that responded to sunlight in ways our laboratories could not yet replicate. Others speculated about layered materials that could redistribute heat or absorb radiation differently across the surface. Yet a quieter faction began to wonder something more radical. What if it was responding intentionally? What if the object wasn't merely reacting to the sun, but making a decision? The idea seemed absurd, and yet the evidence grew harder to dismiss. Magnetic anomalies began to appear in readings from solar probes positioned nearby. Light polarization patterns fluctuated with improbable precision. The faint trace of radio interference hinted at frequencies that did not correspond to any known natural emissions. Scientists who had spent careers explaining away anomalies suddenly found themselves with no comfortable explanation. This wasn't the first time a visitor from beyond had stirred debate. When Oumuamua passed through our solar system in 2017, its unusual acceleration and shape had sparked similar speculation. But unlike Oumuamua, 3I Atlas remained within observation range long enough for comprehensive study, and what the data showed seemed to defy coincidence. As the object drifted past its closest point to the Sun on October 29th, observatories around the world coordinated for continuous monitoring. They measured, recorded, recalibrated, verified, and yet every measurement told the same unsettling story. 3I Atlas did not behave like a comet. It behaved like something that knew what it was doing. The question whispered in labs and conference calls was both simple and terrifying. Could this be an object from another star system that controls its own activity? Could it be a probe or a relic of a civilization we have never met? Scientists pride themselves on skepticism, on refusing to leap to extraordinary conclusions. But as the data continued to contradict every model, something began to shift in tone. Perhaps, they reasoned, the universe was reminding us that we are still far from understanding its full vocabulary. Perhaps nature itself is more complex, more deliberate than we have ever imagined. Or perhaps, just perhaps, something out there is watching back. What unfolded in the following hours would push this mystery beyond speculation and into the realm of genuine scientific crisis. Because as 3I Atlas moved away from the Sun, its behavior did not normalize, it evolved. And what astronomers detected next would force us to reconsider not just our understanding of comets, but of intelligence itself. When the first full datasets arrived from the array of instruments tracking 3I Atlas, the numbers were so inconsistent with standard models that teams assumed sensor error. Yet after cross-checking data from the European Southern Observatory, the Subaru telescope in Hawaii, NASA's Parker Solar Probe, and the Solar and Heliospheric Observatory, the conclusion became unavoidable. The anomaly was real. At precisely 0.7 astronomical units from the Sun, well within the orbit of Venus, the object's coma collapsed. Its brightness plummeted by 40%, and every spectrographic signature shifted. What should have been a burst of volatile liberation became silence. Dr. Robert Warwick at the University of Hawaii was among the first to notice the irregular spectroscopic lines. For 12 continuous hours, he and his team compared the incoming spectra to every molecular database available. Nothing matched. The emission lines were faint but stable, centered around wavelengths that correspond to no known molecular transitions. It was as if the object were radiating at frequencies of an invented chemistry. Some lines hinted at complex hydrocarbons, chains of carbon and hydrogen far more intricate than those typically found in cometary samples. Others suggested nitrogen compounds bound in unstable configurations that should not persist at such temperatures. A few lines existed in ranges that, under terrestrial conditions, simply do not appear. To call it unusual would have been an understatement. To call it impossible might not have been exaggeration. As Warwick's data reached collaborating institutions, further confusion followed. Infrared imaging from the Atacama Desert Observatory showed an even stranger pattern, a perfectly uniform thermal profile across the entire visible surface of 3I Atlas. Normally, irregular rocky bodies show distinct temperature gradients, hot zones where sunlight strikes directly, cooler regions in shadow, dramatic shifts as materials of differing albedo absorb and emit radiation. But here, the thermal field was smooth. Even under the sun's fierce radiation, there were no discernible hot spots. The distribution remained constant within measurement error. For that to occur naturally, the object would have to possess either a completely homogeneous composition, something contradicted by its complex spectral signature, or some mechanism capable of redistributing heat internally. It was as though energy was being actively managed, as though the object sought equilibrium. At this stage, the consensus fractured. A few researchers argued for exotic but natural explanations, perhaps a shell of conductive metallic compounds spreading heat laterally, or subsurface convection through a porous matrix of gases. Others began whispering comparisons that had long been considered taboo in serious astrophysics: active regulation. The idea that an object could sense its environment and adjust its internal conditions was once confined to speculative fiction. Now the evidence pressed uncomfortably close to that very concept. Meanwhile, photometric teams observed an even more baffling effect. The object's reflectivity, its albedo, nearly doubled during the perihelion passage, rising from approximately 0.04 to nearly 0.09 in under 8 hours. For reference, to alter Earth's reflectivity by such a margin would require covering 1/3 of the planet's surface in bright reflective material. On comets, such changes occur slowly, typically over weeks, as layers of fresh ice are exposed or dust deposits settle. Here, it happened faster than any physical process could reasonably explain, and the direction of change defied logic. Instead of brightening because of increased activity and exposed ices, 3I Atlas brightened as its activity diminished. The surface somehow became more reflective while simultaneously producing less vapor and dust. Parker Solar Probe data soon added another dimension to the mystery. During its scheduled magnetic field scans, the probe detected a localized field emanating from the vicinity of 3I Atlas. Not a diffuse, solar wind-induced field, but a structured magnetic zone distinct from the ambient solar environment. Field strength measured roughly 0.03 nanotesla at a distance of 2 million kilometers, far too strong to originate from a 400-meter body of inert rock and ice. For such a small object to produce measurable magnetism at that range, either ferromagnetic materials had to be arranged in specific configurations or electrical currents had to flow through its interior. Neither condition fits the standard model of cometary physics. Even more perplexing, the magnetic readings pulsed with perfect regularity, oscillations repeating every 4.7 seconds. Natural cometary magnetism, when it exists, is erratic, shaped by interactions with the solar wind. Periodic pulsing implies variable current flow, a dynamic system operating within. The phenomenon triggered emergency sessions across multiple research institutions. NASA convened an unscheduled cross-agency teleconference involving the Jet Propulsion Laboratory, the Goddard Space Flight Center, and external advisors from ESA and JAXA. The recorded minutes, later partially declassified, capture the tension of that meeting. Some participants argued the readings must be instrumental interference, possibly from Parker's sensors interacting with solar flares. Others countered with corroborating data from independent magnetometers stationed on Earth that detected the same rhythm in polarized light reflections. The pattern, they argued, was not noise. Then came the trajectory deviation. High-precision tracking of 3I Atlas had been maintained since its discovery. Gravitational influences from the sun and planets, radiation pressure, and even minute outgassing effects were incorporated into predictive models. When the object reached perihelion, those models projected its path with an expected uncertainty of under 50 kilometers. Yet within 24 hours, its actual position diverged by nearly 800 kilometers. For such a shift to occur naturally, immense jets of gas would have had to erupt from its surface, jets that were never observed. The body changed course without visible propulsion. Astrodynamicists proposed several hypotheses: unobserved outgassing directed away from line-of-sight instruments, gravitational perturbation by an unseen fragment, or miscalculations in solar radiation pressure. Each was tested and ruled out. Even accounting for every conceivable variable, the deviation remained unexplained. To alter trajectory without expelling mass requires either gravitational influence from a hidden object or internal propulsion. No gravitational source was detected, leaving only the latter. By early November, the narrative shifted from mere curiosity to potential paradigm shift. If 3I Atlas was using energy to alter its motion, to regulate temperature, to modulate reflectivity, then the implication was profound. These are not properties of inert matter. They are properties of systems. The language of the research papers subtly changed from object to entity, from cometary nucleus to body exhibiting active processes. Yet extraordinary claims require extraordinary evidence, and the community divided sharply. Dr. Helen Murashko, from the Max Planck Institute for Extraterrestrial Physics, warned against premature conclusions. She suggested that unknown physical phenomena, perhaps electrostatic charging or interactions between magnetic fields and dust grains, could produce apparent regulation effects. Others agreed, noting that cometary science is still young and unpredictable. But skeptics like Warwick pointed out that every alternative explanation required invoking multiple coincidences, each finely tuned to mimic control. Nature, he remarked in one interview, doesn't conspire to appear intelligent. The more the object was studied, the deeper the puzzle became. Radar reflections from Arecibo's archival datasets revealed an unexpected geometry, a near-perfect triaxial symmetry, as if the object's major axis followed precise mathematical ratios. That symmetry persisted despite its irregular brightness curve, suggesting an underlying structure rather than a purely chaotic shape. High-resolution imagery hinted at linear ridges and planar surfaces, features inconsistent with the random fracturing expected of natural ice rock conglomerates. Chemical analysis from the solar orbiter's mass spectrometer added further contradictions. As solar particles interacted with the object, the emitted ions displayed charge-to-mass ratios never previously measured in cometary tails. Certain readings implied the presence of superconducting materials, or at least compounds with extraordinarily low resistivity at cryogenic temperatures. Such materials could, in principle, carry electric current sufficient to generate the pulsing magnetic field observed, but their existence in a natural body remains virtually impossible. The anomalies multiplied. Polarimetric studies indicated that the light scattered from the coma exhibited a coherence pattern resembling diffraction through ordered structures, as though the dust grains were aligned by design rather than random distribution. Radio telescopes, attempting to listen for background emissions, instead detected faint, periodic bursts, too weak to classify as signals, yet too regular to dismiss as noise. Each pulse matched the timing of the magnetic oscillations detected by Parker's solar probe. When plotted together, light variation, magnetism, and radio bursts form synchronized cycles. No known natural mechanism ties those three phenomena in perfect rhythm. As data continued to pour in, theoretical physicists began constructing models to explain the observations. One proposal suggested that 3I Atlas could be a fragment of a larger body, perhaps a shard of a disintegrated planetesimal containing residual magnetohydrodynamic systems. Another theory envisioned a hollow shell with a rotating interior core, generating currents much like a dynamo. But for such an internal rotation to exist, the object would require mechanical integrity far beyond the fragile structures typical of comets. The speculation reached a crescendo when computer simulations demonstrated that the observed thermal equilibrium could be maintained if the object possessed a network of conductive pathways distributing heat at velocities comparable to engineered heat pipes. In human technology, similar systems are used in satellites to manage temperature extremes. The parallel was impossible to ignore. It was around this point that informal discussions began referencing 3I Atlas not as an object, but as a potential artifact. The word carried weight. It implied design, purpose, and by extension, intelligence. Few dared use it in public statements, but behind closed doors, researchers debated the unthinkable. Could this be a probe, a device from another civilization, passing near our sun on a trajectory that allowed detailed observation of stellar activity? The hypothesis gained traction partly because it offered coherence. If 3I Atlas were indeed artificial, the anomalies made sense. The sudden drop in activity could represent a deliberate shutdown sequence, protecting internal systems from overheating at perihelion. The uniform temperature might indicate thermal regulation through active cooling. The albedo increase could result from reflective panels deploying or reorienting to reduce solar absorption. The pulsing magnetic field could be an operational signature, perhaps a power cycle or communication beacon. The trajectory deviation might represent a controlled maneuver to adjust orbital path after solar passage. Each of these interpretations, while extraordinary, aligned neatly with the data. Still, confirmation required evidence beyond indirect observation. Proposals for dedicated missions began to circulate. The European Space Agency considered a fast flyby probe equipped with high-gain spectrometers. NASA evaluated the possibility of retasking one of its deep space assets for an intercept. The Chinese National Space Administration reportedly initiated feasibility studies for a rapid launch using heavy lift vehicles. But the logistics were formidable. The object was moving outward at nearly 20 kilometers per second. Every day lost pushed it another 1.7 million kilometers away. Within months, interception would become nearly impossible with current propulsion technology. As agencies debated, independent researchers pressed ahead with analysis. Machine learning algorithms were trained on the accumulated photometric data, searching for patterns that might reveal intentional modulation. The results were ambiguous but tantalizing. Statistical correlations emerged between the timing of magnetic pulses and the brightness variations. Subtle, but consistent enough to suggest encoded information. When mapped in frequency space, the modulation resembled binary structure. Yet without a known frame of reference, no one could decode it. Skeptics argued that humans are predisposed to see patterns even in randomness. They warned that the entire narrative could be an elaborate case of pareidolia on a planetary scale. Still, the regularity of the observations refused to vanish under scrutiny. Every cross-check, every recalibration reaffirmed that something was indeed oscillating, synchronizing, and evolving in step with solar exposure. The debate grew philosophical. If a machine, launched by an extinct civilization millions of years ago, were passing through our system, how would we recognize it? Would it broadcast in our frequencies? Would it even be functioning by our definition? Perhaps intelligence expresses itself in physics rather than in language. Perhaps the only trace of consciousness we can detect is the defiance of randomness. By December, the international astronomical community issued a rare joint statement acknowledging persistent anomalies inconsistent with standard cometary behavior. Officially, the object remained classified as a probable interstellar comet exhibiting unknown physical processes. Unofficially, conversations among senior researchers betrayed deep unease. The term probable had become a refuge for uncertainty. In the months since, every new observation has only deepened the mystery. The object's rotation rate, once stable, began to fluctuate minutely. Oscillations synchronized with its magnetic pulse frequency. Spectrographic lines shifted again, as though molecular composition were changing. No dust emissions were detected, yet light-scattering patterns continued to evolve. If 3I Atlas is a comet, it is one that refuses to obey the universe's rules. If it is not, then something far greater is passing silently through the solar system, following a trajectory known perhaps only to itself. The data remain on our servers, in our archives, in countless spreadsheets and graphs. Scientists pore over them late into the night, searching for a natural mechanism that can restore comfort to our understanding of the cosmos. And yet, in quieter moments, some admit a different thought, one they scarcely dare to speak aloud. What if we are not witnessing a failure of our models, but a revelation of our smallness? What if, for the first time, we are looking at evidence that intelligence did not begin and end with us? For now, 3I Atlas continues its outward journey, shrinking into the blackness beyond Mars's orbit, trailing questions that may define an era. The answers, if they exist, are fading with every kilometer it travels. Long before Three-Eye Atlas captured the imagination of scientists and the public alike, our understanding of interstellar visitors was limited to distant glimpses of cold geometry and wandering debris. Oumuamua in 2017, Borisov in 2019, each left behind more questions than answers. But Three-Eye Atlas, with its impossible symmetry and deliberate quiet at Perihelion, has become something else entirely. A mirror reflecting both our scientific ambition and our existential curiosity. To understand the scale of this discovery, we must look back to how it began. The object was first catalogued by an automated sky survey running from the Haleakala Observatory in Hawaii, a program designed to detect near-Earth asteroids and potential threats. When the faint, moving dot appeared in the data stream, it seemed unremarkable, a magnitude barely above detection limits, a path intersecting the inner solar system. But within days, the precision of its orbital parameters marked it as something extraordinary. Its hyperbolic trajectory indicated an origin beyond our star. It was not bound by solar gravity. It was merely passing through. Dr. Robert Warwick, now at the center of the storm, had been part of the same survey team that identified Oumuamua years earlier. His voice carries the weight of someone who has seen anomalies dismissed before, only to be vindicated later. He speaks softly about the first nights of observation, the faint pulse in the photometric data, the whispers of complexity hidden in the noise. "We thought it was calibration error," he later said. "But when we cleaned the signal, the pattern was still there." It was subtle, almost like the object was breathing. His words, though poetic, captured what the data implied: regularity where randomness should rule. Warwick's career had been built on studying cometary behavior, the delicate balance between sunlight, sublimation, and motion. Yet Three-Eye Atlas forced him and his colleagues to rethink every assumption. In interviews, he describes his initial resistance. "You don't go looking for extraterrestrial engineering," he said. "You look for physics you don't yet understand." But as more instruments confirmed the uniform temperature, the pulsing magnetism, the trajectory deviations, resistance became harder to maintain. "It's one thing to have data that surprises you," he reflected. "It's another to have data that behaves like it's trying to tell you something." Other scientists followed different paths of inquiry. Dr. Helen Murashko devoted her efforts to modeling potential natural processes that could mimic intentional regulation. Her simulations incorporated layers of exotic ices, metallic inclusions, and electrostatic effects. Some produced partial matches, but none replicated all observed parameters simultaneously. The deeper her models grew, the more they pointed to the same uncomfortable truth. Whatever Three-Eye Atlas was, it operated as a coherent system. She once admitted in a symposium that she no longer thought of it as an object, but as a process, a term that hinted at something dynamic, evolving and perhaps alive in its own mechanical way. As the scientific debate deepened, public fascination grew. For the first time in decades, global attention turned not to conflict or economy, but to the stars. Amateur astronomers began tracking the object using backyard telescopes, their data merging with that of professionals through open repositories. Children wrote letters to observatories asking if the quiet comet was alive. The question itself, though naive, captured something profound about the moment. Humanity was witnessing behavior that blurred the boundary between the inanimate and the intentional. To appreciate the weight of this event, one must also understand the object itself, the enigmatic traveler we now call Three-Eye Atlas. Its estimated diameter is around 400 meters, a body small by planetary standards but immense by technological ones. Its shape, inferred from light curve analysis, resembles a triaxial ellipsoid, a balanced geometry that minimizes drag and disperses heat evenly. Surface albedo readings suggest alternating regions of dark carbonaceous material and reflective compounds, possibly metallic. Some researchers propose that these alternating bands could serve as energy absorbers and reflectors, functioning as passive thermal regulators, much like radiator panels on modern spacecraft. Radar mapping conducted before perihelion hinted at internal cavities or density variations consistent with hollow structures. While natural voids exist in cometary bodies, the distribution in this case appeared deliberate, regular spacing that follows geometric ratios. Some have likened it to the structural reinforcement pattern of a pressure vessel. If true, that would imply engineering on a scale we can scarcely imagine. Its orbital behavior tells an equally intriguing story. 3I Atlas entered our system on a hyperbolic trajectory from the direction of Lyra, a region that also yielded the earliest detected interstellar debris from prior centuries of sky surveys. Its incoming velocity, roughly 26 kilometers per second relative to the Sun, aligns closely with the galactic local standard of rest, a reference frame representing the average motion of stars in our region of the Milky Way. This coincidence has not gone unnoticed. If the object were designed for long-term reconnaissance, such a velocity would allow efficient movement through multiple stellar systems with minimal energy expenditure. After perihelion, the changes became subtler but more telling. The magnetic pulses gradually decreased in amplitude while maintaining the same rhythm. The surface reflectivity stabilized at its elevated level. The spectral lines shifted again, showing emerging peaks in the near ultraviolet, suggesting some process of chemical reorganization, perhaps recharging, perhaps healing. Even now, as it drifts outward beyond the orbit of Mars, faint emissions continue to pulse, detectable only to the most sensitive instruments, but still steady, as though 3I Atlas continues to whisper across the void. To those who favor the artificial hypothesis, these patterns resemble operational cycles. The object could be gathering energy, recalibrating instruments, or transmitting data. To skeptics, it remains an unexplained but natural phenomenon, a manifestation of physics we have yet to codify. Either way, the implications are staggering. If 3I Atlas is indeed artificial, it suggests that long before our species learned to launch satellites, another intelligence mastered interstellar travel. It means the galaxy might already be threaded with quiet machines, wandering observers mapping young civilizations as they rise. Perhaps this one has passed through countless systems, gathering data, cataloging stellar behavior, and moving on without interference. In that interpretation, we are not its destination, merely another data point in an ongoing survey that began eons ago. Alternatively, if it is natural, then its strangeness still redefines our understanding of cosmic formation. It could represent a class of objects forged in environments so alien that our chemistry and physics can scarcely model them. In studying it, we might uncover processes that operate at the boundary of matter and plasma, where magnetic fields sculpt structure and stability in ways unknown to terrestrial laboratories. It could expand the very framework of planetary science, forcing us to redefine what constitutes life, system, and order in the universe. Whatever its nature, the cultural impact is already profound. Humanity has once again been reminded of its smallness and its potential. Space agencies that once competed now find themselves sharing data. For a moment, scientific boundaries blur in the face of a mystery too vast for any nation alone. The renewed discussions about an intercept mission have rekindled a sense of exploration reminiscent of the early 21st century rush toward Mars. Concepts circulate for a small, nuclear-powered probe capable of catching the object before it leaves the solar system entirely. Engineers estimate that a launch within 2 years could still achieve a high-speed flyby. Beyond that window, the object's velocity will make pursuit nearly impossible with current technology. Among the proposals is an ambitious concept called Project Lumen. The idea is simple yet daring: to send a compact spacecraft carrying spectrometers, magnetometers, and high-resolution imaging arrays to within a few hundred kilometers of 3I Atlas. The craft would synchronize its motion using solar sail technology, allowing slight course corrections through photon pressure alone. The mission would aim to determine whether the object emits structured electromagnetic signals, to analyze its surface composition directly, and to capture the first detailed images of its form. If funding and international cooperation align, the mission could launch before the end of the decade. But beyond the engineering and logistics lies a more philosophical question, one that transcends science. What does it mean if 3I Atlas is indeed an artifact? Humanity has long searched the skies for evidence that we are not alone, yet few truly expect an answer within their lifetime. If this object is the product of intelligence, then it is the first tangible bridge between our species and another. A silent emissary traveling through the dark, ancient beyond comprehension, enduring long after its makers are gone. It would be the ultimate proof that consciousness can transcend time and distance, leaving behind machines to wander long after memory fades. And if it is not artificial, if it is merely a quirk of physics playing at design, the revelation remains no less awe-inspiring. It would remind us that the universe is capable of producing structures and behaviors so intricate they mirror intention. It would demonstrate that complexity need not arise from will, that nature itself can simulate intelligence through the poetry of physical law. Either outcome expands the boundary of what we understand life and order to be. As it continues its journey outward, 3I Atlas becomes fainter with each passing week, a dim echo receding into the ocean of stars. Yet its legacy will linger. It has reignited humanity's sense of